nucleophilic addition reactions of aldehydes and the ketones. Hydration of aldehydes and the ketones. Hydration of aldehydes and the ketones is a nucleophilic addition reaction of the aldehydes and the ketones. Here in this case, we are going to add actually the water to aldehydes and the ketones. We add water molecule across a carbonyl group in aldehydes and the ketones. And then what do you get? You get the hydrates, right? You get the hydrates. So here is an example of this addition reaction of water. You add the water to the carbon-oxygen double bond. OH goes to the carbon and hydrogen is going to attack on the oxygen. So you get the two OH groups now on the carbon. So this is called the gym-diol. That means when you add aldehydes and the ketones, when you add water to the aldehydes and the ketones, you get gym-diols, or we call them also hydrates. So if you look at the mechanism, right? If you look at the mechanism of this reaction, this is a two-step process. The first thing is going to attack from the hydroxide, a nucleophile, to the oxygen, to the carbon here, an electron pair shift to the oxygen, and you get alkoxide ion as an intermediate, right? Oxygen with a negative charge, and OH will be here. And then in the second step, it is the attack of the electrophile on the oxygen. So from the water, H positive will attack and it will react with the oxygen. You get the two OH groups, the diol, right? Geminal diols, right? Okay, when you have two OH groups on the same carbon, we call it as a geminal diols, and you get the OH. So we carry out this hydration generally in alkaline medium hydroxide. We use this alkaline medium so that you can increase the reactivity of the carbonyl groups, right? So OH attacks first because OH is a better nucleophile than the water. So when you take it, when you do this hydration in alkaline medium, so hydroxide will attack on it, it will increase the reactivity, and then it is the attack of the electrophile on the oxygen. The hydration of aldehydes and the ketones is not same. It's different in different types of carbonyl groups. Generally, if you have a higher alkyl group attached to the carbon-oxygen double bond, then the reactivity will decrease. Okay, it's going to decrease. You can see here the formaldehyde. If you react with the water and you get the hydrate, this one, when you react with the water, okay, you get a hydrate. The relative rate is much higher than the acetaldehyde, right? Why? Because if you increase the size of the alkyl group here attached to the carbon, that will actually decrease the reactivity of the carbon-oxygen double bond. Okay, overall it will decrease the reactivity, because of this. You can see here we have a carbon-oxygen double bond, right? This is a carbon and this is our oxygen, and this is a double bond over here, and then there are two hydrogen atoms. Now this is much more reactive than the acetaldehyde, because in the acetaldehyde you got here a carbon-oxygen double bond, you have a hydrogen, and you also have here a methyl group. And now methyl is electron donor group, right? There are two factors in it, right? Two factors are responsible for the lesser reactivity of the acetaldehyde. We can say one is the size of this alkyl group. The steric hindrance, right, will be there more, so nucleophile will not be able to attack as quickly as you can see here, right? Because more crowdedness is here, right? There's more crowdedness. And here in this case, if you have an acetone, again you see there are two methyl groups, so crowdedness will again increase. So that's the one factor. And the second factor is the inductive effect, the positive I effect of these alkyl groups. Alkyl group is electron donor. It will increase the it's going to decrease the, so alkyl group will decrease the electron deficiency of the carbon, right? Carbonyl group is polar, so it will decrease the reactivity of the carbon. So here you have two groups, so that's going to decrease the reactivity of the carbon again in this case, right? This is our carbon, this is our oxygen atom. So that means if you increase more and more alkyl groups, if you increase the size of the alkyl groups attached to the carbonyl carbon, then the reactivity is going to decrease much more. You can see here the formaldehyde is very much reactive than the acetaldehyde, and if you have more, a substitution here, that will decrease the reactivity, correct? So that means if you increase the crowdedness, if you increase the electron donating groups around this carbon, right, around this carbonyl group, then it's gonna decrease the reactivity of this aldehyde towards the hydration. Hope you got the concept. Thanks for watching the video. Bye for now.